Dear students, how are you all? I guess everything is going quite well because we are coping up with this situation and we have to. Well, we are in a revision process because we extended the previous session to test session. So in test session is the whole book in the syllabus. So in the revision session we are continuing chapter 5, state of matter and pressure. The name of the chapter is state of matter and pressure. Well, first, pressure. So what is pressure? Though we use word pressure in our everyday conversation in many ways, we are in a very deep pressure. You are frustrated with lots of working pressure, sort of the word we use. The word has a different meaning in physics, but in physics the word has a different meaning. We have talked about applying many kinds of force at different times in previous chapter, but how the force will be applied was untold. For example, you can push a stone with your own hand or two hand or with your whole body. Every time through you apply the force, same amount of force, but the pressure will be different. In the first case, you applied force through the area of your palm. It will apply force F and the area is your palm is A. The pressure is so. What is the differential pressure? The vertical applied force on a surface in unit area is called pressure, denoted by P. So P is equal to F by A. Unit is Newton per meter square, and the popular unit is Pascal or Pascal. Dimension is M L inverse 1 T inverse 2. Okay. Therefore, in second case, because we use two hands, the pressure will be half as the area through which the force is being applied is double. In the third case, if you applied force through your whole body, so the area through which force is applied will be increased more and more pressure will be decreased more. So it's appropriate to use one hand to or two hands to displace a brick or stone. Figure 5.0, you might see it in book. Okay, so the relation between force and pressure area is if force constant, then P proportional to 1 by A. If area is increased, pressure will be decreased, and F equal to PA. That's another unit of force, applying force to pressure. Therefore, area itself is considered as a vector. a vector must have a magnitude and a direction. The amount of area in the magnitude of a vector, the perpendicular on the area of the direction of the vector. Okay. Since pressure is a scalar quantity, it has no direction. It is not necessary because the constant pressure is more necessary for a liquid or gas than the solid. When liquid and gas applied pressure, the actually it doesn't depend on the direction. We will see this very soon. Okay. Now we should do some mathematical problem on in this regard. Math. Mass of an mass of a person. Of a person is 50 kg. Area of one side of a body. Area of one side of of his body is meter square and bottom area of two legs is legs is 0.03 meter square. What pressure will we apply on the floor? Okay, answer. Mass is 50 kg. So weight weight is 490 Newton. Well, though the placement is fixed, so the weight is also fixed. So pressure when lying down F1 by A1, that means 490 by 0.5, that means 980 Pascal. Pressure when standing in both case the weight is same. So see, when the person is lying down, the pressure is less because the area is more. But when the person is standing, the pressure is more, much more than the lying down. Okay, so less pressure is applied when lying down, and for this reason, when we falls quicksand, person lie down, so the applied pressure will become lower, and it does not submerge quicksand. So when we trap on a quicksand, we shouldn't stand vertically, rather we should lie down on it. So we can manage our manage sinking down. Okay. Again, the opposite of is also true. If the area of a force applied is less, then the pressure increases. The area of a sharp edge on the nail is very small. So when the sharp point of nail is placed on a wood or wall and the hammer on the flat black head on the nail, so the force exert pressure through the sharp point of the wood or wall. As the area is sharp edge and the nail is just a point, so pressure is very high and the nail can easily penetrate the wood wall. This is also true in the case of knife. In sharp edge is narrow, so it can apply more pressure and it possible to cut easily. Another name of the unit pressure is Pascal. We have told you when 1 meter force applied in one area of 1 meter, so we get 1 Pascal. What is 1 Pascal? The answer is when 1 Newton force is applied on an area of 1 meter square, the amount of pressure is 1 Pascal. Now we discuss about this density. Well, we also need a clear idea about density before understanding the pressure of liquid or gas, because density is embedded in any form or any source or any case of liquid and gas. Density is the amount of mass per unit volume. So what is its definition? The of amount of mass for an object is called density, denoted by rho unit is kg per meter cube. So rho equal to m by v. Dimension is you better look the table 5.0 in your book. There is some there is a chart or table. There's some density of things are written there. You should memorize it. It may come in say an objective matter. Well, density is some familiar substances agent. So here is a good thing to remember. If temperature increases or decreases, volume of a substance can be increased or decreases since there is no change in mass. The density of substance may change with the temperature. Well, there's a issue. We should remember the density of substance may change with temperature. With temperature. Okay. For this, when we talk about density of substance, usually we need to mention the temperature which density is measured. Okay. So math. See the math very clearly. It will give you a good idea about density. Okay. 0.25 kg salt is dissolved in water. Is dissolved water kgs, so that the total volume becomes 12 cc. Find density. Water. One cc of 1 centimeter cube equal to 10 to the power minus 6 meter cube. So when salt is mixed, there is a salty water. Density of salty water salted water rho equal to here. The beginning mass was 1 kg, then we added 0.25 kg with it, and volume is 1200 10 to the power minus 6. So if we have a calculation of it, so what we have 1.25 divided by 1200 10 to the power minus 6, what we get 1.04 kg per meter cube. T is 1.04 kg per meter cube. Well, that's for today. Next class we'll discuss far more about density. Okay, till then, be good, be safe, Allah Hafiz.